Hello, hello. Am I audible? Hello, hello. Am I audible? Hello. Uh, so I'll just write down a problem, and I'll start in a bit. So I guess the screen is visible. So here goes the problem. There are n people standing in a circle numbered 1, 2, up to n. The first person has a gun. He shoots the second person and gives the gun to the third person. The third person similarly kills the fourth person and gives the gun to the fifth person. Okay. So this process continues on. So they are standing in a circle like this, and so on, say, and this person is n. So n and n1 are standing next to each other. This is n minus 1, and so on, say. So the first person gets the gun and kills number 2. Then third person gets the gun and gets the gun and kills number 4, and this continues, right? So the question is, who survives? So okay, so I'll this is just a warm-up question. So try this, and then we'll start off with number theoretic functions. Okay, so just a sec. So this is a warm-up. Hint. So Hint 1. What happens when n is equal to 2 to the power of k or some k? And hint 2, when there are 2 to the power of k plus m many players, who has the gun after m people have died? Okay. So is the question clear? Just write it down in the chat box or something, maybe, so that I can understand. Clear to you guys? Hello? Yeah. So is the problem clear? So let me break this down. Question 1. Try it for smaller values. Try to find out who survives for the smaller values. Question 2. If n is equal to 2 to the power of k for some integer k, who survives? Question 3. If n is equal to the power of k plus m for some integers k and m, where 2 to the power of k is greater than m, then who has the gun when m people are dead? Okay, so for a small case, like say 1, 2, and 3, for the simple case 1 and 2, 1 kills 2, right? So 1 survives. Here 1 kills 2, 3 has the gun, 3 kills 1. So 3 survives, right? Okay, for 4, what happens? 1, 2, 3, 4. 1 kills 2, 3 kills 4. Gun is with 1, 1 kills 3, right? So 1 survives, right? Similarly, say for 5, 1, 2, 3, 4, 5. If we check, what happens? 1 kills 2, 3 kills 4, 5 kills 1. Gun is with 3, right? So 3 kills 5, right? So this is a survivor. So survives. So this is what happens for the small cases, right? So now what happens when this is of the form 2 to the power of k? So for this, let us check. Right? So for this, what happens? So we have an arrangement like this: 1, 2, 3, 4, dot 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 dot. This is 2 to the power of n. This is 2 to the power of n minus 1, and so on, right? Okay, so what happens? 1 kills 2, 2 is dead. 3 kills 4, 4 is dead. This goes on, right? So what are the numbers that are remaining? So if I write it down like this, the numbers that are
The
remaining,
odd numbers will remain, I think.
yes, right, for in the first step. So the next circle, so the next circle looks like this after one step. So let me just erase this. So after one step, how does it look? What does it look like? So 1, 3, 5, 7, 9, dot 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 dot. This should be what? This one?
2 to the power k minus 1.
N minus 1. Okay, so
Okay, yeah.
yeah, fine. Okay, so now what happens? Can you tell me the next step?
So 1 kills 3,
Yes,
then 5
this
kills 7.
and so on, right?
Yes.
So let me what so how many numbers how many people died in the first step? So the question now is, just
So
let me
10.
2 to the power n minus 1.
just a sec, so let me write down the question. So how many people died?
2 to the power n minus 1.
Yes, is it clear how many people died? Because you eliminated all the even numbers, right? How many even numbers were there?
Sir, I think minus 1 in the power.
Oh yeah, I have just a sec, sorry. Yeah, so this is what I meant is this, like, right, it gets halved, right, the population. Yes.
Yes.
Yes, sir.
Okay, so now there are 2 to the power of n minus 1 people remaining. So what was the problem that we started with? Here there were 2 to the power of n people, right? Now we have how many? to the power n minus 1 remaining. Like this many died and this many still remain, right? So how many people? In the second circle,
2 to the power n minus 2.
right? The same number, right? Like the number who died. Just a second.
2 to the power n minus 2.
Here, here, how many people are there?
2 to the power n minus 1.
Yes, right? Because these two add up, right? This should give you 2 to the power of n. Initially, there were 2 to the power of n people. After one round, there are 2 to the power of n minus 1, right? So in this round, what it should be? This should be 2 to the power n minus 2, right?
Yes.
Yes.
So now, can you guess what happens? Who is the survivor?
1.
Who?
1. The first
Yes.
person.
The first person, right? So, okay. So now we know that the first person always survives in this scenario, right?
So why I didn't understand?
Okay, okay. So in this circle, there are 2 to the power of n minus 2 many people, right?
Yes.
So 1, 5, 9, like this.
Yes.
Who survives this one, this circle? Like 1 kills 5,
Yes.
right? And so on. So in all of these, which one is the common survivor, right? This one is the common survivor. He always
Okay.
gets the gun first and he kills the next one. So the thing is, after the round completes, who gets the gun? So one gets the gun, right? Every time. So he is
Yes.
surviving.
Okay.
Because one gets the gun after each round. Right?
Yes, sir.
Okay, so now what should be the next logical question to ask? So what did we prove right now? We proved that one is the survivor whenever we have 2 to the power of n number of people for some 2 to the power k number of people for some k, right?
Yes.
Okay. So the next logical question would be, so now see, any number can be represented in this form, right? 2 to the power of k plus m, where 2 to the power of k is greater than m, right? Do you agree? And m is greater than equal to 0. So do you agree with this? Any integer. Any integer can be written in this form, right? Right?
Yes, sir.
Yes.
Okay. So let's go back to the previous page. So this we know that the first person survives. Okay. So when there are 2 to the power of k plus m many people, like where 2 to the power k is greater than m and this is greater than equal to 0. So who has the gun after m people have died? Say suppose x, just a sec. Say suppose x. So what this x should be so that m people die from this. So this is kind of a arc, right, of the whole circle. So suppose at this point, when the gun is with X, then at that point of time, we should have 2 to the power of n many people. That means m people should have died. Right? Okay. So now I'll give you guys, both of you guys, so there are 3 right now. So I'll give you guys 2 minutes and give me the answer, like this Diganto Bhattacharya account, right? In this one, the answers in private chat, right? I'll give you guys 3 minutes. So the question that is, I'll simplify the question. I need a value. So when there are 100 people, like when n is equal to 100, what's the answer? I need the answer just. So
Answer means who will have the gun?
like no, who survives? So the game is clear, right? So this is like a Russian roulette. So who survives? So the answer, the question is who survives?
Okay, sir.
Got it? Is it clear, right? So
Yes,
this
sir.
is
Clear.
okay. 3 minutes. And don't say anything. Like just write it down in the chat box in the Diganta Bhattacharya account, right? Not in that this one, because I don't have the access to the chat screen right now from that screen. Okay. Yeah. Okay. And then after we discuss this solution, we'll go to number theoretic functions with some problem discussion, of course. Yeah. Hello. So I got two answers. So I'm waiting for the third answer. Okay. So let me start. So the answer is 73, right? So
Yes, sir.
two of you got it correct. Good job. So I'll explain it once. Why this is the case. So okay, host sir, you go ahead. Do you want to explain?
Yes, sir. Sir, while I was doing the solution, I have observed that like while I was calculating some with some random numbers, I have observed that it is like we have to convert the number first the original number into binary number and shift the left means the left digit of the number, the leftmost digit of the number to the rightmost part. We have to do that. I have means after using that, then I have found that for example, if the function is f of n plus 2 to the power k, then it will be 2n plus 1. So in that way, I have done it.
Good, very good. So the yeah, so the you got, gave me the general answer. So very good. So the general answer for this is to say what did I write? M. So it would be 2 m plus 1.
Sir, I tried with some random values of m actually, like m equals to 1, 2, 3, and found this pattern.
Right. So can you prove it? Why this is 2m plus 1? So I understand what Kosab did. So that's actually a proof. So can you prove it like how I did? So this is actually proving why this should be 2m plus 1. So what's the answer for this? Like who has the gun when m people die? 2m plus 1, right? So if you okay, so let me write down a whole solution in a page. So just a second. Okay, so just a sec. I'll turn off my audio. I'll just write it down and then I'll turn on the audio. Yes. So is it clear now?
Can I explain the second last point which you wrote?
Yeah. So the person with the gun, when m people are dead, survives when there are 2n plus m many people with 0 less than m less than 2 to the power of n, right? So if there are 2 to the power n plus m many people, so 1, 2, 3, dot, 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 so on. So the last person is 2 to the power n plus m, right? This one is 2 to the power n plus m minus 1 and so on. So I want to check the point when m people are dead. M people are dead. In this setup. So when m people are dead, it's not necessarily a cycle, right? So when is who has the gun when m people are dead? So this is one people number 2 dies, so one person dies, so the gun is with 3. So when one one person is dead, the gun is with the person 3, right? When the second person is killed, which is number 4, the gun is with 5. So the gun goes to the 2m plus 1th person, right? So here is 2m plus 1 somewhere, right? So before this is 2m. So 2m was dead. So just like the even numbers were dead, right? So when the even number is 2m, the gun is with 2m plus 1, and we have m dead people, right? So after this point, we have only 2 to the power n many people remaining, right?
Yes, sir.
So, and the problem is basically this one: when there are 2 to the power n many players, one survives. So the one here in this case is this, right? Because I am observing the game after m people have died. So right now in this setup, we have 2 to the power n many people. The person with the gun is the first person. So 2m plus 1 is the person with the gun right now. So when the process starts from here, he will be the one remaining, right? Because as we saw here, so it goes into this setup. And the first person survives. So in this case, 2m plus 1 will survive, right? So is this clear now?
Yes, sir. Now clear.
Okay. So we'll go to number theoretic functions now. So do you guys know what is the greatest integer function?
Yes.
Yes, sir.
Okay. So I'll go directly to the theorem. Just let me write it down for the sake of definition here, then, and then I'll go to some theorems and results. So x is equal to right. We write it like this, and right. This is the equality over here, right? Okay. So let's dive into a theorem directly. So theorem. Let alpha and beta are real numbers. So element of real numbers. and a is an integer and n is an element of natural numbers, then we have the following. So one box of alpha plus a equal to box of alpha plus a to box of alpha by n is equal to box of alpha by n box. And the third one is, so just verify if they're true, and then if they're true, prove them. Okay, so the third one is alpha plus beta is less than equal to alpha plus beta, and this is less than equal to alpha plus beta plus 1, right? So clear these three? So the task is to verify and prove. Okay, so I'll prove the first one, which is very easy. The task would for you guys would be to do these two, and I'll give you some time to think about these two. So I'll just do the first one, then I'll give you some time to try out these two. Okay, so just let us look at the first one.
Sir, you have
So
written A belongs to what?
a belongs to z, like integers.
Okay, it is Z. Okay.
Yes, like I'm like my handwriting is very poor in this digital setup, so don't mind. If you don't understand what I'm writing, just feel free to ask. Okay. So the proof for the first one. So let m equal to alpha plus a. Okay. So I'm just assuming some value for the left hand side. So then what do I have? So m is less than equal to alpha plus a, and this is less than equal to or less than. So this should be strictly less than, right? Because this should be a fraction. So or might be equal, right? So real numbers, I told alpha is a real number. So yeah. So is this clear, or what this should be? So tell me. From here I can write this. So is it correct, or it would should it be strictly less than? Okay, so let's see. M minus a. This should be less than equal to alpha minus alpha, right? And this is less than equal to. So just let me clear this out. Yeah. So m minus a is less than equal less than equal to alpha m minus a plus 1. Right? Okay. So this inequality should be strict because I assume this to be m to be the value, right? Otherwise, it would have been m plus 1 itself. So these are strict inequalities. Now, what does this mean? So this implies m minus a is equal to box of alpha so that is what we wanted, right? This is m. So okay, so proof of 2. So I'll give you guys 5 minutes. Try this proof. If someone is done, just let me know in the private chat. So I'll let you guys go ahead with the proof. We'll check whether it's correct or not, right? And verify if these are correct or not first. Okay. So is it clear the question? Just let me know once. So any luck with the problems? Hello?
Sir, I have tried.
Okay. No, just tell me your approach, what you are trying. Like keep me involved. So
Yes, first I have taken alpha equal to k plus L, where k is an integer and L is between 0 and 1.
okay.
Then I have to prove that the greatest integer function of k plus L by n is equal to greatest integer function of k by n.
Right.
Now I have assumed that the greatest integer function of k by n is equal to q. So q will be an integer.
Right.
So as L lies between 0 and 1 and n is an integer. So L is always less than n. So I can say that nq minus n is less than nq minus L. And from that I have proved that q minus k by n plus L by n is less than 1. So I can prove that the left hand side and right hand side are same.
For the second one. Okay. Good. For the third one.
Now third one I have not yet tried.
Okay. So try the third one. I'll write down the proof for everyone. So just let me write down the proof, and after I finish writing down the proof, tell me if you don't understand anything. Fine.
Okay, and is it my one correct?
Yes, I think what you are saying is mostly the same thing that I'll be doing. Like I didn't understand the last few steps because like I need to see what exactly you are saying, but I think you are correct, right? So just once I am finished with writing down the proof, just check whether you have written down the same thing. I think you are saying the same thing,
Okay.
right? Okay. Yes. So is the proof clear? Hello. I think you are telling the same thing, right?
Yes.
So just try for 2 minutes. Say, I'll just you have the problem written down, right? So I'll just prepare this note a bit, and then I'll go to the proof of this one. Okay. Okay.
Yes, sir. Question number 3 done.
Hello. Yeah. So uh, I'll give you the problem. Like one, you have done it. So just check it. Check when I write the solution whether it's same with yours or not. I'll give you the next problem so that you can have a head start. What about others? So have you done the third problem and have you understood the second one? Then I can move on. I'll write down the solution for the third one and then I can move on with the next problem. So what about others?
So can you explain the last part of the second problem?
Last part of the second problem, like this problem, right? Like the greatest integer one.
Yes.
Yeah, just a sec. Okay, so this is the second part. So just a sec. Yes, let me do this also. I'll give you guys this note afterwards, the class, so that you can have a look at it. Okay, so I'll start off with the next problem. Just a sec. Okay, so let's start off with the proof of the third one, and I think this would be enough. So, and I'll give you the problem. So, do you guys know Euler's function and Fermat's last little theorem and last theorem?
I know the little theorem, but last theorem I don't know.
Okay, okay, fine, no problem. So, just let me give you the problem, then I'll start off with the solution. So you can try, those who have done it, they can try the next one, like the problem. So, okay, so the problem is this. If n is a positive integer, then box of right? Is the problem clear? So this is the problem, right?
You have to prove it.
Yes. So I'll start off with the proof of 3. I'll write down the proof, and if anyone has any doubts. Okay, so just a sec. Hello. So is the proof clear?
So why did you write that the alpha plus beta will be less than the integer greatest is the function of alpha plus beta is the function of beta plus 2?
So doesn't that come from the definition? Like, okay, so is this correct? So just let me write it down. Is this correct?
Yes.
And is this correct?
Yes, it is also correct.
So add them up.
Okay, got it.
Right? Any doubts? Feel
No,
free
sir.
to ask. Yeah. So, and is the next problem clear? Is the next problem clear, everyone?
Yes.
Okay. So, and have you checked out the hint? So try squaring it and check modulo 4. You know something about squares and modulo 4s,
Yes,
right?
sir.
Yes, sir.
Okay. So that's the hint. So you know the rule. So private chat. So what's the time now? 24. So we don't have much time. I'll give you 3 minutes for this. Fine. 23, 28. I'll start off with the solution. And if anyone has solved it before that time, just in the private chat, let me know how you have done it. So I'll give you a chance to explain how you did. And if it's correct, you can check it out with my solution. Fine. Okay. So try it out. Hello. Yeah. So, any luck with the problem? Anyone? So let us square it. So what do we get? Four n plus one. So check this. So is it clear
So
why?
now 2n plus 3.
Sorry. Yeah. Just thanks. This was correct. This was wrong. Yeah. Sorry. Yeah. So this is corrected.
So how did you write the first statement? Can you say?
This one,
Yes.
like this one comes from squaring, right? Like, okay, so the idea, right? Why I did this. So the problem was given to be this, right?
Yes.
So if this is true, so you should have checked with smaller values, right? This is true, right?
Yes.
Okay, so step one would be to check smaller values. Okay, so if this is true, so this means that, so what about this right hand side? So this right hand side is box of 4n plus root of 4n plus 2, right?
Yes.
Okay, so is this correct?
Yes.
Right? Because this is less than, which is less than, right?
Yes, sir.
So similarly, now you understand. Okay, so this is step two. So what about step three? You understand. I'll do the similar step for the other side. So 4n plus 1, the root of this is less than this, which in turn, like, okay, so explain this step. So this side, do you see why this is true? Can anyone explain?
Which one?
Like the other side, this side. You see that this is, So why should this be true?
That means you want to ask why root over of 4n plus 1 will be less than the box of root over of
Yes,
4n plus 2.
yes. And is it correct?
I don't think it is correct.
So why it is wrong? Give me an example where it is wrong. It should be clear where it is wrong. Like there should be specific modulo 4 numbers for which this should be wrong.
I think it is not strictly less than. It can be less than or equal.
Yes. So can you give me an example?
Okay, I'm thinking.
So which one is he saying wrong?
This thing. If I write this is not correct.
Yes, sir. I think suppose n equal to 2. Okay.
Okay.
Then your claim is that root over of 9 is less than box of root over of 10.
Right.
But
So
if you take box of root over of 10, it will be
that
3.
should, yes. So this is, whenever this is a perfect square, you will have issues, right?
Yes, exactly.
Okay. Right. So is it clear now? Okay. So going back to the proof, why is this correct? Like what I wrote here.
You just squared all the three sides.
Yes. But the idea is this, right? So the motivation is this. I want to bound this particular thing. But I see, what do I see? That for certain numbers, this is not a strict inequality, right? Okay. So this is correct up to this. So what do I have now from here? So let me just erase this. So this is clear, right? Why this is true.
So actually, I think we have first assumed what it is said to be true.
Yes. So what we can say after this, like,
That means you have first assumed that it is holding true, and then later on you will say that it is bound to be true.
yes, like this is my motivation. Yes. So, but it won't work if I don't get a certain equality, right? So what I'm aiming for is this. So see, if this holds, then we are done, right?
Why we are done?
So think about it. So look at the problem once again. So if I say that this is true, so I assume this to be true for right now. Assume this to be true. So what happens then?
Then I think root over of box of root over of n plus root over of n plus 1 is equal to box of root over of 4n plus
4n plus
3.
yes. So then so what do we have? So let me write it down. So we have box of root over of n plus root over of n plus 1, this is equal to box of root over of 4n plus 2, right? And I'm claiming that this is true also. So this is equal to box of 4n plus 3. Okay, first things first. Why is this true? Like, why is this assumption? So just like it would be very silly to write assume this to be true because it is true. Can anyone give me a quick argument why this is true for any n? Okay, so see that
That any two consecutive numbers cannot be simultaneously squared.
not exactly that. What about this? 4n and 4n plus 1. They can both be squares, right?
Yes, that holds only for n equal to 0.
Yes. N equal to 0. Yeah, n equal to 0, but still, uh,
Equals is 0, yeah, it holds.
uh, but like, so okay, so your argument would be like this, right? So there is only one square and those values would be taking the same squares. But what if 4n plus 3 is a square? Like, what if root over of 4n plus 3 is a square? Then what happens?
Actually, 4n plus 3 can never be a square number.
Exactly. So the main argument is this, right? That 4n plus 2 and 4n plus 3 are not
Can never be
squares,
square.
right? These are not squares.
Yes, by the
So
congruity of 4, right?
yes, exactly. So it should be 0 or 1 mod 4. Just a sec. 0 or 1 mod 4 to be perfect square. So this is true. So our claim that 4n plus 2 box of this is equal to box of root over of 4n plus 3. Now what happens? Yeah. So just let me write down one thing here. So I don't want to go outside this line. So right.
So once again, I think it will be less than equal to.
Yes, yes. Here, right?
Yes.
Yes. So now what can you say?
So sir, if 4n plus 1 is a square number,
Yes.
then the box of root over of n and root over of n plus 1 will be equal to root over of 4n plus 1. And similarly, for 4n plus 2 root over, the box will be equal to 4n plus 1 root.
Yes. So all the values would be equal to what?
Yes.
So is it clear to everyone? Hello? Just respond so that I'll be able to understand if it is okay with everyone. Right? Okay. So just let me box it out. Okay. So let us go to the next thing, next problem. So let me write down the problem. Let's box it out. Okay. So the problem is let f of n is equal to n plus box of root n. Prove that for every positive integer m, the sequence m f of m, f of m, and so on contains at least one square of an integer. Okay. So just a sec. And the next problem would be to do this. I'll just turn off the mic for a second. I'll just write down the problems in theory. Okay, so the problems are clear, I guess, the two problems. Yeah. So the theorem says if a and b are relatively prime natural numbers, then summation k running from 1 to a minus 1 GIF of kb by a is equal to summation k running from 1 to b minus 1 ka by b, which is equal to a minus 1 times b minus 1 by 2 when a and b are relatively prime natural numbers. The problems are also clear, I guess. So I'll give you guys a quick proof of this, and I'll send you guys this whole note. I expect you guys to do this example and these two proofs for these two things. I'll give you the proof for this theorem right now. Okay, fine. Just type it down in the chat box if it's okay. So I'll give you guys a quick proof of this, and then we'll be done for today's session, right?
So what have you written in the next page? Is it another problem?
Yeah, it's an example. Like it would be very clear after I write down this proof how you can use this theorem to do this. So try also this one. If you can't do it, I'll start next day's class with this proof and then these two proofs. These two are the homeworks, right? The ones in red. This one is a pretty known problem. So, okay, right? Fine. Okay, so I'll write down the proof. Then any doubts? No, the drill. Okay, that's Yes. So is it fine now? The proof?
Yes, I have one doubt.
Yeah. Go ahead.
You have written that there are a minus 1 into b minus 1 lattice point.
Yes.
But I think it, why not a into b simply?
Okay. What about these lattice points? How many lattice points are here actually?
4.
So do you see my point? Like, do you see the rectangle first? So
That
on
means
the,
you want to exclude the one which are along the edge.
yes, obviously. And do you see why? Like the claim says there are no lattice point on the line this except at the endpoints, right?
Yes, that is always true. That I can understand.
So just think it up in this term. What am I exactly summing up? I am summing up uh, this fractional part of kb by a, where k runs from 1 to a minus 1, right? So this is essentially xb by a, right?
Yes.
So I am trying to trace out how this line moves, right?
So how can the number of lattice points be equally shared in the parts of the rectangle?
Okay, so let's do this. So I'll give you this right now after the class. Uh, try to draw the diagram and see what is happening. In the next class, I'll start off with the diagram, and if anyone of you can come up with this diagram, it would be very helpful. Then the next day, I'll start off with diagrams like this. So try to draw the diagram here. So this is, I'll just start off initially like this is 0 0 a comma 0 0 comma b a comma b. Okay, so try to draw the diagram and see why this argument is correct, what I'm exactly saying. If there's no diagram, you won't be able to understand. So just a sec. And for greatest integer functions and equalities like this, it's very important for you to be able to draw this type of diagrams. So before giving you the proof, like I'll give you the proof for this next in the next class. Not the proof is here, like the diagram. I'll explain you by the diagram. But since I want you guys to actually look at this diagram for a bit, because otherwise the next problems that will come would be very difficult to tackle, right? So just okay, just let me write down two problems here. So if in so the next class would be in the next week, right? So you have 7 days. So I guess you, most of you, three of you would be able to figure out what I meant in this diagram. Then try to do these two problems. So you have a lot of homework. So you'll see. And in the next classes, we'll solve these problems first. Then I'll give you three more theorems, and I'll then give you homeworks on those. And I'll do some problems in class. So that way we can solve a lot of problem at once. Okay. So you will see why I am giving you these two problems, because it is very closely related to the same diagram. Okay. So, okay. Actually, let me give you three problems. I remember three problems right now. There would be more, but At this point, I remember these three only. So okay. So let's write down the problem. Problem 1. Prove that if n is an element of natural numbers, then minimum of k element of natural numbers k plus n by k, box of n by k is equal to, so this is not related to this diagram, but this is related to the problem that we did with 4 n's. Okay, so this is the first problem. Problem 2.
So the outer part is a bracket, right?
This is the bracket for minimum, like the minimum k. So there's a minimum operator. So for that, I gave them brackets. Got it?
Yes.
Okay. So the next problem is let n be the number of integer solutions to xy less than equal to n with x greater than 0, y greater than 0, then prove okay, so let me write this down first. N is equal to summation k running from 1 to small n box of n by k. This is equal to twice of summation 1 k is equal to root n, and I think this root n minus of box of. So just verify this if this is true or not. This is, I think this is true. Okay. And if it's true, prove it. So like the expression might be slightly wrong, but I am not sure. I am not exactly sure whether it's wrong. I think this is correct. You can just check. So okay. And this is very similar to the one like a similar diagram that you need to draw. You need to draw xy less than equal to n and see what this summation exactly means. And the last one is this. If
Is the summation in the right hand side only of n by k box or the entire thing?
which is what? The summation?
The right hand side summation,
Yes.
it is for the entire n by k box or the n by k box minus box of n root n square.
This is the sum is only for the first part, like 2 times. I have not given brackets, right?
Okay.
Yes. On second thought, just a bit. No, I think the summation is outside, like the whole thing. Yeah, you are correct. just verify. Okay, I'm not exactly sure, so just verify. This should be I mean, one of them is certainly wrong, right? You will see. So I'll start off with this side actually. So in the next class, if you guys can figure it out, fine. Otherwise, I'll start off with this. I'll check it out once whether the summation was this or not. But this one is fine. This one, the one that I'm writing, is a pretty popular identity that I'm writing right now. So this is A and B should be odd. A and B are odd. Then we have summation yeah. So this is fine. So this is called the Eisenstein's identity. Eisenstein's identity. So try out these problems and just draw this out and you will figure out why this is true. Like why the minus ones. Okay. So fine. Let's stop here today. I'll send you guys this document via Orco, sir. Right? Okay.
So when will you send it?
I'll send it to Orco, sir, right now. So you should contact him for the documents, I guess.
Okay.
Right? Fine.
Okay.
Yeah. Okay. So let's end the class here today. Bye, guys.